we have which among the given pool of structures of atoms are presented in Lewis dot structures. Okay? So we have quite a bit of. So which among our atoms presented in valid, that's important, Lewis dot structure. So what this one's asking for really is, specifically for atoms especially, is how many valence electrons does these typically have, okay? So let's start with the first one, carbon. It has 1, 2, 3, 4. Now how many valence electrons is that? Well, let's look at our periodic table here, okay? We have be the 14th column of the periodic table. So typically that means it has 4 valence electrons. So that matches. You can also quickly use your electron configuration to figure this out. We have, just to make sure, we start at helium because that's the most recent noble gas. And then we have 2s2, 2p2. And with that being said, those 2 and 2 match what the carbon's saying here. So this is indeed a valid Lewis dot structure. Okay? Now, N, nitrogen, is presented like this, where it's supposed to be neutral, but it has 4 electrons. With that being said, you can see that nitrogen is actually next to carbon. Okay, that means I actually want to have 1 more electron as a valence electron. So we're already looking a little bit shaky. So then with that being said, let's see here if you can actually solidify that with electric configuration. Start with helium as well. And then we do, just to make sure I'm doing it correct, 2s2, 2p3, and that means you should have 5 electrons. So this right here, this nitrogen as a valid Lewis dot structure is not it. Okay? So now we're going to try oxygen. So oxygen is going through 6 valence electrons. Okay? And according to the periodic table, it's on column 16. Okay, so that's a good start. And also the children, sorry, it's on column 16. I meant children, I meant that it's electron configuration. So like it's baby electrons. Starts with helium. Okay. And now we have 2s2, 2p4. Okay, which does add to 6. And considering that one has 6 as well, this is also a valid Lewis dot structure. So far we have 2. What else do we have? Now we're working with ions, okay? So now we have C4+, okay? And C4+ is represented by having carbon with full 8 electrons. Well, let's see if that's possible. So 4+ means that you lost 4 electrons. So think of it as kind of literally going back in the periodic table to like almost a different element. Okay? But not really, it's just a representation of the electrons. So carbon lost 4. That's 4 plus means. We have 1, 2, 3, 4. Oops, so 1, 2, 3, 4. It's almost treated like a helium atom in terms of electrons, because carbon's lost 4 electrons out of the 6 it had. Okay, so then it would only really be helium. With that being said, helium actually only has 2 electrons instead of 8. So this right here would not be a valid Lewis dot structure, because that's way too many electrons for something that just lost 4 of them. Nitrogen, on the other hand, okay, it says 3 bitus. So we have nitrogen, okay, Then we have the 3 minus right there. I think we'll drink some water real quick. But the point being is that we have that 3 minus, meaning that it gained 3 electrons. So nitrogen gained 3 electrons. Look at the periodic table. We have it right here. And so 1, 2, 3. It would look like neon. And neon has 8 valence electrons. So actually when it got that 3 minus, it should have gone up to 8 valence electrons. As you can see here, there's no chance of that having the 8 electrons. So it's crossed out. Because that's 3 minus. Kind of went the wrong way. Now we have O, oxygen, 2 minus. So we have like this. So with that being said though, we only have 1, 2, 3, 4, 5, 6. Okay, so that's still 6 electrons, but 2 minus actually will put spaces like that nitrogen, where they were both trying to pretend to be neon. So they actually both do want 8 valence electrons, but this one only has 6 of them. So with that being said, this wouldn't be valid Lewis dot structure, because a valid one would actually have 2 more electrons there for it to actually be O2 minus. With that being said, let me just go through these to just write the correct one. If it was really C4 plus, it would have no valence electrons because it just got rid of all 4 like up here. If this was N3 minus, it would be like this, where N is completely filled and it's perfectly fine with that. And oxygen, we have this as well, because it's going to be completely filled. 2 more electrons. So with that being said, based on this, carbon is good, nitrogen is not, oxygen is good, and then the carbon and oxygen are both not. The carbon, nitrogen, and oxygen, the ion forms, are not good. So that means we really only had there, based on this, is that our carbon and oxygen are the only ones that truly followed the valid Lewis dot structure. Alright, time for a quick water break here.